Yes, I'm recording. Okay, chapter 20, urinary system. Let's go. Okay, so the renal artery enters into the kidney. It's got to bring blood. You got to bring blood to the kidney. The kidney is usually spoken of as a filtration device. It's a lot more than a filtration device, although it is that too. So here are the arteries that branch into the kidney, and they branch and branch and branch, and of course they get smaller and smaller into these tissues that are called afferent arterioles and efferent arterioles. This is the path. This is the path into the kidney, then the path out of the kidney. It's a lot easier to look at it when you actually see pictures. So here you are. Over here, let me get my pen. Okay. So over here you have a cast model. This is a plasticized model of the kidney. The yellow thing over here, that's the ureter. The red thing, of course, is the renal artery that's bringing blood into the kidney. And then you have the renal vein that is taking blood out of the kidney. As the blood comes into the kidney, the blood gets diverted out to the renal cortex, which is, as you can see here, this is the renal cortex. And a cortex of anything is the outside of it, the outer portion of it. Inside is the renal medulla, right? This part here. So that's just the inner portion. The blood gets ferreted to the outside of the kidney into the renal cortex, and then it gets diverted into these structures that are known as nephrons. And we're going to talk a lot about nephrons. But you got to get the blood out there first, and you got to get the blood into the appropriate, I'll say, filtration mechanisms in order to take out the things in the blood that you want to take out, but you have to leave the things in the blood that you need to leave in the blood, and that's the tricky thing about the kidney. That's what the kidney's job really is. So these are the last slide showed the names of all of these different blood vessels and the pathway of the flow of blood through the kidney, into the kidney, and out of the kidney. We're going to get into the more specific details in the next slide after this, but this is the path. The path comes into the inner part of the kidney, which is called the renal pelvis. Then it goes through the medulla out to the cortex, then into the nephrons. The kidney does its magic. We're going to talk all about that magic. And it separates out urine, and urine flows down into these collecting tubules here. And that's the path of urine. All right. And urine gets diverted, I guess, I should finally say that urine eventually gets diverted out the ureter. And the ureter will lead to the urinary bladder. All right, so let's go to the next slide. All right, so blood gets diverted out to the renal cortex, and it has to go through these specialized structures. They're still blood vessels, so these compact circular structures there. That's called a glomerulus. A glomerulus is nothing more than a network of, oh, there's my pointer, a network of blood vessels that looks like a ball of yarn, essentially. But these are all blood vessels, and so the blood comes into the glomerulus, flows through the glomerulus, and then flows out of the glomerulus. And we'll talk about all the structures that you have to come across in order to get to the glomerulus. The glomerulus is this network of blood vessels, but it is surrounded by this other structure here called the glomerular capsule. Okay, so that whole thing, this is the glomerulus, and then there is a capsule around that. That is the very, very important structural and really, frankly, functional unit of the kidney and how the kidney works. So this is the blood flow. You have to have a renal artery. You get into the kidney. There are lobular arteries But eventually you get to what's called an afferent arteriole. Make sure that you understand one letter. This is one letter difference. The thing that brings blood into the glomerulus is the afferent arteriole. Then you flow through the glomerulus, and then you leave the glomerulus. Blood leaves the glomerulus through the efferent arteriole. And then it goes into the paratubular capillaries, and we'll talk about what those are and why those are so important. Get your A's and E's in line. Afferent leads into the glomerulus. Efferent leads out of the glomerulus. This is the path. Right? Renal artery, that's outside the kidney, but it leads into the kidney. The renal artery leads to the lobular arteries, or interlobular arteries, and the arcuate artery. And we won't worry about the cortical radiate artery. What I'm really concerned about is this one. I mean, obviously the renal artery, I'm very concerned about that one too. Of course, I want you to know that. Afferent arteriole, then you get into the glomerular capsule. Then you leave the glomerulus through the efferent arteriole. Eventually, and then you have to go through the paratubular capillaries. Those are going to be important to know as well. That's also called the vasa recta. And then eventually, blah, 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 you get into interlobular veins and eventually leave the kidney through the renal vein. Urine, of course, will leave the kidney through the ureter. All right. You really need to understand how a nephron is built in order to understand how the kidney works. In each kidney, each one, you have two kidneys. I've always wondered why you have two kidneys and not two hearts, but that's not the way things are built. This is the way they are. You have about 1 million nephrons, and they're called functional units because they're the actual thing that is doing the filtration and the reabsorption and all the functional things that we're going to talk about in a moment. Those are called nephrons. Very, very important structures to understand. Here's a nephron. A nephron is composed of two parts. I'm going to break this down when you see the picture coming up in the next few slides. Two parts. Number one, renal corpuscle. The renal corpuscle is, you've already seen a glomerulus. Glomerulus is the tangled up blood vessels surrounded by a capsule, the renal capsule, which is also called Bowman's capsule. So glomerulus, the tangled blood vessels, and the capsule surrounding the glomerulus. That is called the renal corpuscle. Second part, number two, coming out of the renal corpuscle are the renal tubule, or tubules. We break it up into separate sections, but these two parts, the renal corpuscle and the renal tubule. So the tubule extends from the glomerular capsule to the collecting duct. There are three portions of the renal tubule that you need to understand and need to know. There is the proximal tubule, or what is known as the proximal convoluted tubule. You'll see why it's convoluted in a moment. But proximal tubule, that's one part of it. Then there is the nephron loop. Now, it used to be referred to as this secondary name here, the loop of Henle. As I've mentioned to you, we're trying to get away from naming anatomical structures after the scientists or the doctors who discovered them. So Henle must have discovered this thing. We're now referring it more as the nephron loop rather than the loop of Henle. And then, after that, is the distal tubule, or distal convoluted tubule. So, renal tubule is composed of, the first part is the proximal tubule, the next part is called the nephron loop, the last part is called the distal tubule. From the distal tubule, you'll end up taking urine, essentially. At this point, at the point of the distal tubule, you're really dealing with urine. And that leads into the collecting tubule, or collecting duct. The collecting duct will then take urine out of the body. There are other things that happen in the collecting duct, but essentially the collecting duct leads to the ureter. Here they are in picture form. So, the flow of blood comes in through the renal artery. You branch and branch, you end up in coming into the glomerulus afferent arteriole. Blood flows this way. Into the afferent arteriole, into the glomerulus. This whole thing is the glomerulus. Now they've taken the glomerulus and they've expanded it over in this picture over here. Made it bigger. What you can see here is the red part is the afferent arteriole, or the glomerulus, that is flowing around inside Bowman's capsule. And it is surrounded by a cellular type called a podocyte. A podocyte, think of this term podo, right? Podo means podiatrist. Podocyte has little feet on it. We consider these, all of these little branches, all those little branches, these little tiny branches that are surrounding the artery. All of these little branches are considered little feet. So those are, as I say, the process of the podocyte. Now you have a podocyte here, and then you have another one over here, and those, the processes will intermix with each other, or interdigitate, kind of like if you took your two hands and put your fingers together. Your fingers would interdigitate with each other. In between your fingers, you would have a little bit of space. In a glomerulus, we call that place, or that little space, we call that a slit pore. So you have little pores where things can get filtered through. Now that's going to be an important understanding in order to understand the function of the kidney and how a nephron works. So, to recap, blood flows into the afferent arteriole, into the glomerulus. It flows through the glomerulus, but gets filtered through the podocytes. And the podocytes have these slit pores that help to filter materials that get into this space. That space right there. So there is some stuff that gets literally filtered into this area, and that area, of course, this whole thing is Bowman's capsule. And whatever gets filtered into there ends up going that direction. And that direction is into the tubular system of the kidney, of the nephron. We'll talk about how that all works, but that's how stuff gets in there. It flows into here. Things that are small enough to get through those slits get into the tubular system. Things that are not small enough do not get in there, and they continue on out. So they go out the afferent arteriole. Things like red blood cells. Things like bigger proteins. They can't fit through the slits. Right. So this whole thing, recap. Renal corpuscle. The whole thing is a renal corpuscle. It consists of the glomerulus and the glomerular capsule. There are podocytes that have slits in between them that help to start the filtration process. So where does that stuff go? All right, so here's the glomerulus again. You have the capsule, glomerular capsule, around the glomerulus. I told you there's podocytes around the glomerulus, the blood vessels in the glomerulus. And so that starts the filtration system. So whatever can get through ends up going this direction. This twisty curly tube here is called the proximal tubule. That whole thing is the proximal tubule. So this filtered stuff, what's known at this point, it's known as glomerular filtrate. Not urine. It is not urine yet. The glomerular filtrate is inside the proximal convoluted tubule. Right, so here's the proximal tubule. Then it has to go into the nephron loop, so it's traveling down this way and turns the corner, comes back up. So it goes into the nephron loop next, and then it goes into the distal tubule, or sometimes you'll see it called the distal convoluted tubule, this twisty thing over here. Eventually, they don't have the collecting duct here, but I will draw it in. Here is a collecting duct. Everything ends up going in from the distal convoluted tubule down that way into the collecting duct. That ends up going out the kidney through the ureter. So here it is, blown up, it's bigger form. Again, afferent arteriole. You now know that means blood going in. Here's the glomerulus. Some things get filtered through there, some things don't. We're going to have a table of what gets through and what doesn't. Whatever doesn't leaves through the efferent arteriole and keeps on going. That way. These arrows do not look good. The filtered fluid at this point, at that point, is known as glomerular filtrate. It is not urine. That is not urine. We have 180 liters of glomerular filtrate every day. 180 liters. You certainly don't produce 180 liters of urine. So most of the stuff that ends up in these tubules gets pulled back into your body. A good way to think about the kidney is to think of, I kind of like the analogy that if you were going to clean out a refrigerator, it's nasty, there's mold growing on some stuff, it's dirty, it's sticky because something spilled there, a couple of months ago. You're going to clean out your fridge. What do? You go in, you pull everything out of the fridge. You pull it out, you put it on the counter. You clean it, you clean it, you clean it, and then you look at the stuff on the counter and you decide, what do I want to go back in there? Well, I'm not going to put the moldy applesauce back in there. I'm going to throw that away. Your kidney is kind of like that too. It filters a whole bunch of stuff, but it wants most of that stuff back. But some of it doesn't want back. So all that stuff is called, as I say, is called glomerular filtrate. It is in the proximal tubule. Now your proximal tubule has a chance to decide, do I want this stuff or do I not want this stuff? Do I want to throw it away? Do I want to pull it back? We're going to talk about what it throws away and what it pulls back in a moment. But the nephron is the site of urine production, but it is not urine at this. This is not urine. Not urine right there. Urine is over here. This is essentially urine. Once it gets over into the collecting tubule, that's urine. So, not urine up there. Yes, it is urine over here. Nephron consists of a renal corpuscle, and the renal corpuscle is just this, and a renal tubule. And the renal tubule is everything from here to there. Right? Two parts. Renal corpuscle and renal tubule. That's a nephron. Here's the molecular, or the microscopic structure, microscopic anatomy of a nephron. Why do I keep, oh, there it is, whoopsie. Oh, well, I didn't really want that to do that. But this is a glomerulus there, under a microscope. Here's a glomerulus there, right? So, these are, you can see collecting tubules, collecting ducts over there, long, skinny things. So this is a microscopic view of that, a little harder to see. It's a little easier to draw pictures of this stuff. All right, here's the path. So if you're going to make urine, urine is, urine leaves through here. Urine leaves through the collecting duct. That's where you have urine. Prior to that, really, it's not urine. You're forming urine. So it has to go through the glomerulus. It has to go through the glomerular capsule. It has to get into the proximal tubule. And of course, these are the parts of the nephron. It has to get into the nephron loop. Right? It's got to go, and we even separate the nephron loop into two parts too. We say there's a descending part of the loop, and there is an ascending part. So when it's going down, it's doing one thing. When it comes back up, it's doing a different thing. We're going to talk all about that. It eventually gets into the distal convoluted tubule, into the collecting duct, and now you formed urine. Now at this point you have urine. Urine now has to get sent out of the body. It goes through the minor calyx, the major calyx. These are just bigger and bigger tubes that take urine out of the body. Renal pelvis, you're still in the, at this point, you're still in the kidney. Right? So that's K. I'm going to put K. That's the kidney. You're still in the kidney. Once you get to the ureter, now you're out of the kidney. Now you're on your way to the urinary bladder. Of course, urinary bladder, that's the storage place for urine. And then out the urethra, that's the elimination structure. That's how urine gets out of the body. From the point of the collecting duct on out of the body, you don't change the urine at all. It's simply, the rest of it is just ductwork and kidney and structures to hold the urine and structures to get rid of the urine. That's it. Okay. Now, this comes back to one of the first slides that we saw. Right, blood comes in this way, and it goes out to the renal cortex. And then it ends up in the glomerulus, the Bowman's capsule. It goes through the proximal convoluted tubule, and then dips down this way through the nephron loop, back up into the distal convoluted tubule, and then out the collecting tubule, out the ureter, etc. That's how urine gets out. We will talk about these structures in a moment, called juxtamedullary neurons, or I'm sorry, juxtamedullary nephrons. We're going to talk about where they are. They still do the same thing, but they have another special function, special feature that is only part of the juxtamedullary nephrons that the regular, as we say, cortical nephrons don't get involved with what the juxtamedullary nephrons do. And we'll talk about that in a minute. And as it says here, the juxtamedullary nephrons are a fairly small percentage. Okay, most of your nephrons are going to be cortical nephrons. Now, okay, the Juxtaglomerular apparatus. I love the names of things in physiology. Juxtaglomerular apparatus. What does that mean? Well, your kidney does more than filter blood. It does a lot more than that. One of the things that it is involved with is the regulation of blood pressure in the body. And we'll get to why that's so important, but just accept that it is involved in the regulation of blood pressure. Blood pressure regulation starts with the kidney's production of this hormone called renin. Renin is we'll see. It's a protein that will be involved in the regulation of blood pressure eventually. So there's a special portion of the juxtaglomerular apparatus that is involved in essentially measuring blood pressure in your body and then adjusting blood pressure based on this, based on what it finds. And it does so through the hormone renin that it that it produces. It produces renin. Now, so the way to think about a kidney is you have to think you need blood flow to flow into your kidney. Of course, you already knew that. But if you are sitting and resting or lying down, you have a certain amount of blood pressure. Your heart is pumping at a certain rate. The pressure in your arteries is being guided and monitored. And so everything's fine. And then you decide, I'm going to get up and I'm going to go for a walk. All right, so you get up. Well, getting up and walking involves, you have to have a higher heart rate and you have to have higher blood pressure. because now instead of lying down, now you're vertical. Verticality requires that you have increased blood pressure to get blood up to your brain. But increased blood pressure would also increase pressure to every single organ inside your body, including the kidney. So if your kidney gets more blood pressure, and more blood to it, and it can't regulate, if it couldn't regulate the blood pressure, or the pressure of the blood coming into it, then you would start to have more flow of blood through the kidney apparatus, through Bowman's capsule. You would have more filtrate, and you would produce more urine. And so every time you stood up and walked around, you would start to have to pee. That would be very inconvenient, and that would be not a good way to monitor or guide the formation of urine, right? You would like to, the kidney needs to be able to regulate the amount of fluid that is going through it in any given time. And so it does that through the blood pressure alterations in the afferent and efferent arterioles going into the glomerulus. But we'll see how that works in a moment. But it also has to regulate blood pressure throughout the body. And that's what the Juxtaglomerular apparatus, ugh, I hate these words, what that is all about. So it's a structure that regulates the secretion of renin. Renin is the hormone. The top portion of the ascending limb of the nephron loop of each nephron passes between the afferent and efferent arterioles. At this point, the ascending limb comes in contact with the afferent arteriole to form the juxtaglomerular apparatus. These are nice words. Doesn't mean a thing until you look at it. Two tissues that you need to be aware of. Juxtaglomerular cells. Okay? And then this structure called the macula densa. So let's see pictures of that. So here you go. Here is the afferent arteriole. That means blood is flowing this way into the glomerulus. Right? These cells here are smooth muscle cells that regulate the by constricting they can decrease blood flow, or by opening up they can allow more blood to flow in. So that's smooth muscle. Now blood's going to flow that way. Whoops, this thing is weird. Blood flows into the glomerulus, and you have the podocytes around there. But right at that place where the afferent arteriole comes into the glomerulus and the efferent arteriole leaves the glomerulus, right there where these tissues come together, there is this structure. There it is, the juxtaglomerular apparatus. So you have specialized cells right here. These are the cells that produce renin. Why are they right there? Because they can get a sense of how much pressure, how much blood pressure is coming into the glomerulus, how much pressure is leaving the glomerulus. So it can start to control how much pressure, it senses how much pressure there is in these arterioles at that point. Now this is the ascending limb of the nephron loop. Now we're going to see where that is, and that is, this is the descending limb. This is the ascending limb on this side. Going up. We call it that because that's the flow of the glomerular filtrate through the tubule system. And you see right there, that's the thing that they're making bigger over here. So juxtaglomerular cells, these are the cells that are going to feel for blood pressure changes. If they feel that they need to, they're going to produce this hormone called renin. We'll see what renin does in a minute. This whole process, the whole hormonal control of blood pressure is known as, and you will need to know this, it is known as the renin-angiotensin system. So commit that to memory. Renin-angiotensin system. In the end, what it does is it increases, this whole system increases blood pressure. So it senses low blood pressure, and it's going to increase the blood pressure if it feels that that's what's needed. All right, let's get to urine formation. There's 3 steps in urine formation. First off, there is glomerular filtration. The result of glomerular filtration is blood coming through the afferent arteriole, going into the glomerulus, and then you get a filtrate. That is called a glomerular filtrate. The next step is to, inside these tubules, there's a whole bunch of stuff in there that you want. There's sodium, there's potassium, there's chloride. All this stuff can go through the podocytes, right through the slits in the podocytes, and glucose can get through there. So you have all these ions, you have certain small proteins, you have very, very important things that ended up filtered into the proximal convoluted tubule. A lot of that stuff you want back. In fact, most of that stuff you really want back. The process by which your kidney reclaims the stuff that's in the tubule system, that process is called reabsorption. Reabsorption. I would tell you, as a matter of first course, yes, it's called tubular reabsorption. Yes, that's true. But I would tell you, forget the tubular part at this point. Just think, I want to reabsorb some of the things that are in those tubes. I don't want to give up all of my glucose. I don't want to give up all of my sodium and my potassium and my chloride and my bicarbonate ion. I don't want to give up that stuff. I want it back. If your kidney wants it back, if your body wants it back, it means it has to reabsorb it. Now, there are certain things in your blood that didn't get filtered. Say metabolites of certain medications, urea. There are other things that in the blood that all of this stuff didn't get filtered out, as you would like to get rid of waste products. If you want to get rid of waste products and you want to put them in the urine, then you need to secrete those things. All right, so summary. First step of the process is filtration. You're going to filter pretty much everything. Anything that's small enough to get through the filtration system, you're going to have a filtrate, a glomerular filtrate. And then the stuff you want back, you're going to reabsorb it. And the stuff that you want to get rid of, you're going to secrete it. Those are the 3 steps. Filtration, reabsorption, secretion. Boom, done. All right, so here we go. Afferent arteriole, blood's going that way. It hits the glomerulus, it goes through the podocytes, through the slits, filtered fluid, right? So that is, at this point, that is called a glomerular filtrate. There's a bunch of stuff in there that you would like back. If you want it back, you have to reabsorb it. Reabsorption means I'm taking it out of the tubes and I'm putting it back into the capillary. That's it. That's reabsorption. If there are things inside the arteriole, the efferent arteriole, that you really would like to get rid of, well, you need to secrete those things. That means you have to, in order to secrete something, you have to take it from a capillary and stick it into the tubes. So, filtrate at the glomerulus through into Bowman's capsule. That's a filtrate. Stuff you want back, you reabsorb it. The stuff you don't want, you secrete it. The stuff you don't want ends up in urine, right? Here we go. That's the point here, right? You're making urine. The stuff you do want ends up in venous blood flow, and it gets sent back through the renal veins out to the rest of the body. That's it. That's the process through the kidney. Okay? So, first step, glomerular filtration. This is the first step of urine formation, but do not be confused here. You do not have urine at this point. That is not urine. Okay? Substances move from the blood in the glomerulus into the glomerular capsule. Water, small dissolved molecules, and ions. Those are the things that can be made through. So that's called a filtrate. Large molecules, large proteins, can't make it through. Blood cells can't make it through. White blood cells, red blood cells, doesn't matter. They can't get through there. So they're staying in the blood. Large proteins, they can't make it. They're staying in the blood. There's other processes to get rid of that stuff. The glomerular capillaries are many times more permeable than other capillaries. So the glomerulus are very leaky. They have what are called fenestrae, or you can say they're fenestrated. That just means they have big holes, big pores, that allows things to get through. Glomerular filtrate, I've already said this, is formed as substances filter from the glomerulus into the glomerular capsule. So here it is again. As I say, afferents bring blood in, efferents bring blood out. Here is the glomerulus with the podocytes on it, slits. Now, we blow this picture up, we make it bigger. You can see the little slits, right? The little tiny slits. So here's some slits here, some slits there, and there, and there. So a little bit of stuff gets through. Whatever gets through there gets in between the glomerulus and the capsule. So there's this intercapsular space. This stuff that gets through is called a glomerular filtrate. If it gets into the glomerular filtrate, it's pretty likely to get into the proximal tubule and go that way. It's not guaranteed. We're going to get into the what are the forces that help this stuff filter. All right. Now, in order to push things through the fenestrae inside Bowman's capsule, you have to have a pressure. All right, so filtration pressure. Oh, there it is. Filtration pressure. So what are the pressures on that? Of course, the main force that pushes things through by filtration, the main force, of course, is, as you might expect, hydrostatic pressure. That just means blood pressure, right? Blood pressure is pushing things into the glomerulus. Okay, so that's a pressure. Well, if you've got slits inside the blood vessels inside the glomerulus, you're going to get some leak because you've got pressure behind them. Okay. The afferent arteriole has a large diameter. The efferent arteriole has a smaller diameter. All right, so that creates more of a back pressure. Resistance in the efferent arteriole increases the blood pressure in the glomerulus. And that favors filtration. Of course it does, right? Okay, so in the end, net filtration pressure is, of course, the force favoring filtration versus the forces opposing filtration. What are the forces opposing filtration? Well, force favoring filtration, we already talked about it. Hydrostatic pressure. It's blood pressure. Okay? The forces opposing filtration are, there is glomerular capillary osmotic pressure. That just means the pressure of the fluid inside the glomerulus wants to get back inside. Because of osmotic pressure, it wants to force itself back into the blood vessels. It's less than hydrostatic pressure, but still, it wants to come back in. And then there is also, inside the capsule, inside Bowman's capsule, there is a slight hydrostatic pressure in there that wants to push back. It's less, but it's still there. It wants to push back. All right, so here are the forces. Here it is in picture form. Blood flow comes in. There is a lot of pressure pushing that way. But there's a little bit of pressure, right? So here is the capsule, as I said, exerts a slight hydrostatic pressure in that direction. And the colloid, well, or as osmotic, as you think of it as osmotic pressure is also pushing that direction. Okay, so you got two smaller forces pushing one way, one big force pushing the other way. Let's add them up. So you have glomerular hydrostatic pressure, 60 millimeters of mercury coming in. That's the force of blood coming in. Here is osmotic pressure pushing back the other direction. Here is hydrostatic pressure of the capsule pushing back. Add them up. You get 60 minus 32 minus 18. Overall, you get about a plus 10 millimeter force that's pushing blood through Bowman's capsule into the proximal convoluted tubule. You would like to maintain that 10 millimeters of mercury as close to 10 as you possibly can. You really don't want this to vary very much. So here's the overall effect. Your blood goes through your kidney. 5 liters of blood goes through your kidney every minute. Right, so you have 125 milliliters per minute goes through each kidney. That averages 180 liters of blood flowing through the kidneys every single day. Well, certainly you don't make that much urine. How much urine do you make? This much urine. Maybe about a liter, a little bit more than a liter. They're telling you 2.5 liters. That'd be a lot of urine. You're drinking a lot of water if you're making that much urine. A liter to 2 liters of urine a day versus 180 liters that goes in. So you are filtering. This is a very interesting factoid right there. You are filtering your blood 60 times a day. That's how important it is for your kidneys to look at your blood to see what's in there. And only a small percentage, a very small percentage of that is actually excreted as urine. So that's the beauty of the kidneys. It sees a lot of blood many, many times a day and only sends out the necessary quantity of urine so that you don't become dehydrated because you're peeing out too much.